Hey everybody, welcome back to Newton Mutant channel as I bring you a different interesting problem today. This is more of a logic puzzle. I'm sure you will like this one. Andrew and Tristan are playing a game. Both are given as many pebbles as required. A bucket is placed in front of the players, and they take turns putting 1, 2, or 3 pebbles into the bucket. The player who puts the 25th pebble into the bucket wins the game. Suppose Andrew starts the game, who will win? This is a puzzle that's really intuitive and worth taking some time to think about. I invite you to pause this right here and try to think of an approach to arrive at an answer. Okay then, let's get started. First, let's assume that some player can actually win. That is, player X, who can be either Andrew or Tristan, has a winning strategy. Here, my approach is something I'd like to term as a backward computation. That is, for player X to win, or for him to put the 25th pebble into the bucket, what should be the necessary condition? Don't panic now. The necessary condition is that player X should actually put in the 21st pebble. Let me explain how I arrived at that statement. Let's assume that the game has progressed so far for a few turns, and now, player X has put in the 21st pebble in. Note that a player can put in only 1, 2, or 3 pebbles at a time. So now we have 21 pebbles in the bucket, and the next turn is for player Y. As player Y has 3 choices, 3 different scenarios can happen. Let's evaluate each one of them. Scenario 1. Player Y puts in only 1 pebble. Now the bucket has a total of 22 pebbles. Next, it's the turn of player X. Player X will definitely put in 3 pebbles, so the bucket reaches the pebble count of 25, and player X wins. Scenario 2. Player Y puts in 2 pebbles this time. Now the bucket has a total of 23 pebbles. Next, it's the turn of player X. Player X will definitely put in 2 pebbles, so the bucket reaches the pebble count of 25, and player X wins in this scenario as well. Scenario 3, the final scenario. Player Y puts in 3 pebbles. Now the bucket has a total of 24 pebbles. Next, it's the turn of player X, and same as before, player X wins in this scenario as well, this time by putting in only 1 pebble, to make the total pebble count 25. Alright, so we have shown that for player X, to put in the 25th pebble and win, the necessary condition is that he must put in the 21st pebble. As long as player X puts in the 21st pebble, he is guaranteed to win in his next turn, irrespective of what player Y does. On a similar line of thought, taking a backward approach, we can easily show that, for player X to put in the 21st pebble, he must put in the 17th pebble. And, for him to put in the 17th pebble, he needs to put in the 13th pebble, and so on. It becomes clear that to ensure player X's win, the count he needs to arrive at in each of his turns is found by subtracting 4 from the previous term, starting from 25 and going backwards. So, we find out that player X needs to put in the first pebble to guarantee his win. Hence, the first player to start the game can always win, and in this case it is Andrew. Hope you enjoyed solving this problem with me, and that my approach was clear. Let me know your thoughts below in the comments section. Please like this video and drop a subscribe to my channel. More cool stuff are coming. Goodbye till next time.